lesson is called 4 ways of representing functions. 4 ways of representing functions. Right, and that's what we're going to be looking at. Remember, I want you to learn actively. I don't want you to watch me making notes. I write this down so that you can write it down. Okay, so the first way is verbally. Okay, that's double L. The second way is algebraically, and we're going to look at examples of each of these. The third way is what we call numerically, or in a tabular method. And the fourth way is what we will call graphically. Or graphical representation of the function. So those are essentially the 4 ways of representing functions. Now we're going to take a thin pen in order to move forward. It's 4 ways of representing functions. The first is verbally, algebraically, numerically, in a tabular method, or in a graphical method, right? So let's see how we do this. I'm going to start off with verbal. Now, do you know what is the definition of something that is verbal? Now, most people think that this means that you will say it, say or speak, right? Most people think that is what we are talking about. But the reality is verbal does not mean to say or speak, right? This isn't particularly correct, not correct, right? Now I'm going to get the dictionary and show you what verbal means. Okay, so in here we can see the dictionary. It's got definition of verbal: of or relating to or consisting of words, right? Verbal instructions: of or relating to or involving words rather than meaning or substance. You can see that here they speak of spoken rather than written, but the correct meaning is actually when it involves words. So let's talk about that. So I wouldn't say this is particularly correct. It's not really incorrect, but it's not the most popular definition. So when we talk about something being verbal, it means it involves words. So I'm going to put down there correct. It involves the use of words, right? Now, according to the people of grammar and language, when we say something is to speak or spoken word, the correct term is orally, right? But when we talk about verbally, we are talking about involves the use of words. Involves the use of words, right? Verbally involves the use of words. To say or to speak is not particularly correct because this over here refers to something being expressed orally. Orally, right? Okay, so I'm going to take a simple function and I'm going to talk about how we represent it. I'm going to say, if I want to describe the sides of a square, so let me draw a square, seeing that we have, let's take a different color in case that hurts your eyes a little bit. So there you can see that's a square. Let's assume all sides there are equivalent. That's S, S, right? S, 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 where S simply represents the variable that describes each length of the square, right? S is the length. S represents the length of side of square. The length of the side of the square, right? Now, let's talk about a verbal representation of a function, right? The perimeter, and you should be writing this down, and I encourage you to write, because you know human nature requires us to write, because this is how we engrave the neural patterns, right? The perimeter of a square is 4 times the length of one of its sides. Now all the sides are the same, right? So you can write down the perimeter of a square is 4 times the length of one of its sides. That's the verbal representation of how we look at this particular square. Okay, now let me look at an algebraic method. Well, algebraically, let's choose a different color. Algebraically, we would say that the perimeter, which I'm going to represent with P, is equal to 4 multiplied by S. Remember 4S just means 4 times S, right? I don't need to put the dot really there in between, but that's 4 times S. Okay. So there we have the verbal representation of the perimeter of a square, and there we have the algebraic representation of the perimeter of a square, which is just the length of the side of it. So, I mean, we're really looking at the distance around this object, okay? Okay, so now let's look at a table method, numerically or in a tabular method. Oh my word, numerical or tabular. So in a numerical or tabular method, you have most often seen this as a table, right? I'm guessing that you have most often seen this as a table. So I'm going to draw a table. Let me just see if that's the thinnest. Oh, there's no different sizes for it, but let's just work with what we've got. So let's do that. I'm going to draw a table, beautiful table. That's not the right one. Let's take a line, right? Let's just do a few of that there. Okay, I think that is sufficient. So let me just erase this part over here. Okay, there we go. Right, so let's get back on with this and let's talk about the numerical method, right? The numerical method is what we call either the numerical method or the tabular method. So you either use a table or you use what we call an ordered set of pairs, an ordered pair, right? Or an n tuple. So in this case, an ordered pair, it uses an ordered pair, right? So what does an ordered pair look like? Often you see it as x and y, where this is what we call the independent variable and this is the dependent variable. In other words, this is what you throw in and this is what you get out. And if we look at this very carefully, it could have been P and S or P and Q or whatever you want to call it. It depends on what you're throwing in and what you're getting out. So this is my input usually with functions, and this is my output usually, right? Okay, so let us look at this. Now we're going to use the same example. If we go one back, you can see that clearly we said that the perimeter of a square, in other words, the length of the side of the square, is 4 times the side. So if this is length 1, and this is length 1, and that is length 1, and that is length 1, and I ask you, you're enclosing a farm that is square in shape, how much fencing do you need if each side of the farm is 1 kilometer long? Then you're just going to tell me it's 1 plus 1 plus 1 plus 1 because it's a square. And similarly with that, people, all it means is I take 4 times 1 because it's a square and I get the perimeter of the square. So in this case, let's talk about this. We are going to look at an ordered pair where this represents the length for the example that I'm using, the comparison that I'm using. This is the length of a side. And this output over here will be the perimeter of that square based on that length of the side. Okay, now another way to look at the algebraic one, I'm just coming back to this, is that we call this a rule by representing it using a rule. In grade 8 and 9, in grade 5, 6, 7, you often call it a rule, right? Over here, I'm going to use the length of the side I'm going to represent with S, and the perimeter I'm going to represent with P. And according to the rule that we came up with, the rule was P equals 4 multiplied by S, which we write as 4S. Okay. Now, depending on the value of the S, it means that we're going to get different types of squares. So if I take the first square and I say, okay, let me draw that square over here. Let's just choose a different color. Red seems like something we haven't used yet. And let's just draw another one over there. Let's draw a smaller one there. Let's draw a bigger one there. Let's draw a bigger one there. And a bigger one over there. So let's assume that's a square. And let's say that the length of the square here is 2, 2, 2, and 2. And the length on this one is 3. Let's just put it over there. 3, 3, and 3, right? And the length on this one, let's say it's 4, 4. I think you know where I'm going with this, and 4, right? And this one's going to be 5, 5, 5, and just for the sake of space, I'm going to write this 5 on the inside over there. Okay, let's assume that we work with side length 1, side length 2, now 1 I haven't given you an example, side length 3, side length 4, side length 5, and side length 6, and side length 7. This is the tabular or numerical method of representing a function. Now, as you know, each of these can be expressed as an ordered pair. That's numerical. Tabular means the table. It's 4 times S. So I substitute P of 1, which means I put 4 times 1 in there, and I get 4. Then I put 2 in there, in the value of S, and I see what I get. So the answer here is going to be 4. Now we know that this rule is 4 times whatever S is. So 4 times 2 is 8. Then 4 times 3 is 12. And 4 times 4 is 16. 4 times 5 is 20. Right? 4 times 6, 6, 12, 18 is 24. Okay. 4 times 7 is 28. And you can see that this represents an ordered pair. So if I have to express that ordered pair, I say the first pair is 1 and 4. In other words, when the side length of the square is 1, its perimeter is 4. Similarly, if I look 2 and 8, then I say the side length of each side of the square, then its entire perimeter will be 8. If I look at the next one, I say that side length is 3, but then its perimeter must be 12. And this here is called the numerical method of representing a function. This over here is called the tabular method of representing a function. And that is the third way in which we can represent a function. Okay. Now, 1 and 4, 2 and 8, 3 and 12, 4 and 16, 5 and 20, and so forth. You can clearly see 4 plus 4 plus 4 plus 4 gives me 16, and 4 times 4 is 16. So this square, this diagram over here represents this one over there. Okay, so that's a numerical or the tabular method of representing a function. Let's look at the final one. The final one is graphical method. Okay, graphical. So by means of using a graph on the Cartesian plane. Right, on the Cartesian plane. Now, why can you do this? This is quite simple because to draw things on a Cartesian plane, in order to plot coordinates, all you need to do is find an ordered pair. All you need is ordered pairs. All you need is what? Ordered, ordered pairs, right? So in this case, we're going to represent the ordered pair here, 1 and 4, 2 and 8, 3 and 12, 1 and 4, 2 and 8, 3 and 12, 4 and 16, and so forth. on a Cartesian plane. All it means is you find out where these coordinates are and you join the points. And that's really how you do it. You can use the table, draw the points on the table, and then you can get the graph, right? Now I'm going to take a shortcut. I'm just going to take the rule, which is P is equal to 4 multiplied by S, and I'm going to put that into a graphing calculator, and I'm going to see what I get. And there we go. Y equals 4x is exactly the same as P equals 4S. So now you can see, if I look at 1, 1 touches on 4. That's the coordinate. 1 touches on 4. Right? 2 goes all the way up. So let's just bring that down. Oops. I need to clear the page quickly. So let's look if 1 and 4 is a coordinate. So you go all the way to 1. 1 is here, and 4 is there. That's 1 and 4. That's the point 1 and 4. If you go here, you go all the way up, you have 2 and 8. And by the way, all these other points are also on the function. We only selected certain points in our table method because we could choose which points we want for x, because we said, what if my square has length 1? So we chose length 1 for each side. Then we said, what does it look like, right? Then we said, what if my square has length 2 on each side? And then we chose 2 and we saw what it looks like. If you go to 3, 3 lies over here, and you go all the way up, then that point corresponds to 3 on the x, or 3 on the s axis as we've got it, and 12, and so forth, and you'll go all the way. So this is what we call a graph. And in this particular case, it is a linear graph. Right. Okay, very good. Okay, so that's the 4 ways of representing a function. I hope that you learned something there. Graphical, numerical, and tabular method. Verbal is when we use words. The perimeter of a square is 4 times the length of one of its sides. And algebraically is when we come up with a rule to express it in terms of variables. And those are the 4 ways of representing a function.